Good morning, one and all. I am K. Narsimurthy, working as an assistant professor in the Government First Grade Women's College, Tumkur. I am going to present the video for the course BSc. The subject is Physics. And the paper which I am discussing is Semiconductor Devices, Digital Electronics, Laser and Fiber Optics. The topic which I am discussing today in my video is application of CRO. CRO means it's a cathode ray oscilloscope. In my last video, I have explained the working as well as the construction of this cathode ray oscilloscope in detail. So learning objectives are to examine the waveform in the waveform produced by the CRO, and also to measure the frequency of any AC source, and also to measure the voltage of an AC source, and also to measure the phase difference between the two AC signals. Yes, we will start with the first application, that is the examination of waveform. One of the most important application of CRO is to observe the waveform in the shape of the wave of an voltage in a various type of electronic circuit. We have a different kinds of electronic circuit, and those electronic circuit produces different kind of voltage signals, and the shape of those voltage signals can be seen through this CRO. Just feed the output of that electronic circuit to the one channel of the CRO. You can see beautifully the waveforms, beautifully the voltage signal, output voltage signals in the CRO. The signal under study is applied to the vertical input terminal. There are vertical terminal and an horizontal terminal in the CRO. The signal which has to be studied is given to the vertical input terminal, that is the vertical deflection plate of the CRO. This vertical input terminal is the vertical deflection plate of the CRO. There are two plates over there. One is the vertical deflection plate, another one is the horizontal diffraction plate. Then there are so many various controls knobs are there to adjust the sharpness. One, we can adjust the sharpness of that the waveform, and also we can adjust the focusing, and also we can adjust the number of waves in the monitor just by increasing or decreasing the time per division knobs, and also the height of that wave. Height of that wave also can be adjusted with the voltage per division knob in the CRO. There are a lot of adjustments in the CRO. By doing all the adjustments, we can get a beautiful waveform on the screen. So the waveform can be examined with the help of the CRO. Next application of the CRO is to measure the frequency. So if in a lab we require to measure the frequency of an AC source, of course we have a AC source will have a inbuilt frequency display over there. It display the frequency, but in some cases, in some output, we have to measure the frequency of those signals. You cannot measure the frequency with the help of the multimeter. The multimeter can only measure the current, ammeter, resistance, capacitance, inductance, but it will not measure the frequency. Of course, there are advanced multimeters which do measure the frequency, but on our regular lab multimeters will not measure the frequency, and that too the multimeters are limited to a certain frequencies. The high frequency cannot be measured with an ordinary multimeter. So the only suitable instrument to measure the frequency is the CRO, cathode ray oscilloscope. The thing is, the output of a signal generator, any AC signal generator, the output is applied to the one channel of the CRO. We have two channels in the CRO. Okay, you apply an output of an AC source to one of the channel of the CRO. After giving this AC signal to the CRO, one adjustment we have to make here is the time per division knob is adjusted so that you can see only 2 or 3 cycles. You can see 2 or 3 waveform on the screen. Okay, So adjust the time per division knob such that 2 or 3 cycles signals appears on the screen on the monitor. Okay, so after getting these waveforms on the monitor, the length of one complete wave has to be noted on the horizontal graduated scale. So one complete length means I have shown you in the figure. Okay, so here one complete length of wave in the horizontal direction is from here to here. I mean to say it is nothing but an wavelength. In a sense, it is the distance between 2 points in the same state of vibration. Or you can say it is the distance between the 2 points which are in same phase. Either you select these 2 points which are in same phase, or you select the points which are in the peak, so peak from here to here, horizontal distance from one peak to another peak, that will also gives you the frequency. Or from in the horizontal line itself you take the distance from here to here, so that is also will gives you the frequency, sorry, that is also gives you the wavelength. So once you measure the wavelengths, so time period of the signal can be calculated by multiplying that wavelength with time per division knob. You have a knob in the CRO, and that knob is particularly adjusted for one time per division to get at some desired waveforms on the screen. It may be 1 milliseconds or it may be 2 milliseconds. If the knob is set for 2 milliseconds, you multiply that 2 milliseconds with the wavelength of the wave which is appear on the screen, and that multiplication will gives us the time period of the wave. So time period of the wave can be calculated by that method. After finding the time period, as you know, you can just calculate the frequency out of it by just taking the reciprocal of the time period. So 1 divided by t will gives you the frequency of the wave. So frequency of a wave can be easily found out with the help of the CRO, cathode ray oscilloscope. Right. So move on to the next application. Here the third application is we can measure the voltage of an output signal. Okay. The voltage which we have to be measured is fed to the one of the channel of the CRO. I mean to say signal generator output is fed to the one of the channel of the CRO. Okay, you adjust the voltage for 1 volt using multimeter. In the lab we are doing this. In the lab we are just verifying these applications of CRO, where we are adjusting the voltage of an AC source by 1 volt using the multimeter. Okay, after that the output of that AC source signal generator is applied to one of the channel of the CRO. Okay, after giving the input to the CRO, you just adjust the time per division knob and also the volt per division knob so as to get a good number of waves on the screen, so as to make the measurements of it. That means ideally we keep this time per division knob for 1 milliseconds per division, and also the volt per division knob for 1 volt per division. And after keeping all this waveform, the trace is brought to the center of the screen. If it goes one side, you bring it back to the center of the screen. We have an adjustment for your X movement is also there, Y movement is also there. You bring the waveform to the center of the screen so that it is easy for you to make the measurement over the screen. Alright, now the thing is to measure the peak to peak height. Peak to peak height of the signal is measured directly on the screen. So here is a peak. It is a vertical measurement, right? So this is a measurement along y axis, not an horizontal measurement. Here we are doing the vertical measurement. That is what the peak to peak measurement is. So from this peak to this peak, we are measuring the distance. Okay, how will you measure the distance on the monitor of the CRO? Because you cannot put a scale on the monitor of the CRO. In the CRO itself, there is a graduation. CRO monitor itself, there is a graduation which shows the one box is 1 centimeter. You will have a boxes like this, 1 centimeter, one box. Another one box is for 2 centimeters, 3 centimeters. There will be boxes even in the horizontal direction and also in the vertical direction. Suppose the waveform will be in the one complete box means 1 centimeter. After that, there is another one box. In within the box, you will have a 10 small graduations, which gives you the zero point 0.1 volt. It's zero point 0.1 division. So if it one complete box and one small box will gives you 1.1. One complete box with the two small box will gives you 1.2. Like that, we have a graduations on the monitor of the CRO. We don't need to worry about the doing the measurement with a scale or some measuring instruments. It will be there itself on the monitor. So you make the peak to peak measurement. Height of the signal is measured directly on the screen. Okay. So after measuring the peak to peak, the voltage is calculated by multiplying that peak to peak measured value with the volt per division. Okay. So I'll repeat this. The peak to peak measurements which we did in the vertical scale is multiplied by the volt per division. That will gives you the voltage which we are going to measure. The voltage which we actually fed to the one of the channel of the CRO. Okay, so that is how the voltage measurements can be done with the help of cathode ray oscilloscope. We'll move on to the last application of CRO. So here with the CRO, we can measure the phase difference between the two waves. You have to be very careful with this. So there in the frequency measurements, we require only one wave where we measure the frequency, just measure the one wave length and multiply that with a time per division will give you the frequency. And while measuring the voltage also, we are giving only one output wave to the CRO. There we measure the peak to peak and just multiply the volt per division. That will gives you the voltage. But here, while measuring the frequency of the two signals, you have to obviously feed two signals to the two channels of the CRO. So you have to feed two signals to the two channels of the CRO and set the frequency to 1 kilohertz. And these two signals are connected to X and Y plates of the CRO. So resulting pattern on the screen will be ellipse. Now it is not a waveform because it's a overlapping of two waves. Overlapping of two waves will leads to a ellipse shape here. Now the ellipse is formed on the monitor. Okay. So here the ellipse is brought to the center of the screen by just moving the X movement or by Y movement. By moving both the X and Y movement, you bring the ellipse to the center of the screen. Okay. Uh, with respect to X and Y scale graduation, of course. Now, by measuring A and B, the phase difference phi can be calculated using the formula phi equals tan inverse of A by B. I'll tell you how to measure A and B with a pictorial representation and how to measure the frequency of that. How to measure the phase difference by measuring A and B. So this is the ellipse you will get on the monitor screen of the CRO, and we brought it back to the center of the screen now. Okay, with respect to X and Y axis, we brought this to the center. Look here, this ellipse is cutting the positive Y axis at this point. Okay, so here it is cutting the positive Y axis from that point to the origin. From that point where this ellipse is cutting the positive Y axis, from that point to the origin is the distance A. You measure the distance A, so there will be boxes over there. It is easy for you to look and see the measurements of A. This is the distance of A. After finding A, you have to find B also, the distance B. Here is the peak of the wave. This is the peak of the wave. You draw an horizontal line. This horizontal line from the peak of this ellipse. Okay. So this is the peak of the ellipse. So from peak of the ellipse, you draw an horizontal line. This will touches the y-axis at this point. From this point to the origin, distance is B. Okay. So I'll explain it once again. The peak of this ellipse, you draw an horizontal line which touches the y-axis at this point, and this distance y, this y-axis distance is the B. Okay. Now we found A and B with the ellipse. After finding A and B distances along y-axis, there is a formula to calculate this phase difference between the two waves which we fed to the two channels of the CRO, and that formula is phi equals sine inverse of A by B. Okay, it's a very simple equation, very simple calculation. Just thing is to find the value of A and B correctly. Just to get the ellipse at the center of the wave, you just make the measurements along y-axis, find out A and B, substitute the values of A and B in the formula of phi, which is equals to the tan inverse of A by B. The phase difference between the two waves can be calculated. Okay, so this is one of the special application of the CRO where we can find the phase difference of the two waves, where we cannot measure. Any other instrument of course may not measure the phase difference between the two waves. In the laboratory with these multimeters will never measure the phase difference between the two waves. This is the only instrument which we seen in our laboratories which measure accurately the phase difference between the two waves. And final year BSc students will have this experiment in the lab also, in the 503 paper in the Tumkur University, and you are going to conduct this experiment in the laboratory. You are going to measure the voltage, frequency, and also the phase difference between the two waves in the laboratory with the help of the CRO. And that experiment is prescribed in the Tumkur University syllabus. So theory is also there in the 501 paper, and laboratory experiment will also kept in the same year by the Tumkur University for the 5th semester students. Yeah, some of the books which I have referred, the good book for this is the Sundarajan by College Physics, which is published in 2011, very clearly mentioned about the applications of CRO. Of course, some of the images I have taken from the internet also. Lot of information is available in the web sources. You download the web sources and go on, keep on studying those materials. You will understand these applications of this cathode ray oscilloscope much better. I hope you understand this application of CRO. Thank you very much.